Assalamualaikum and have a nice day. Today we're going to continue chapter 2 part 4B, where we'll be focused on cascode connections. This cascode has a difference between the cascade, where the cascade are separated by the capacitor in between Q1 and Q2. However, in cascode, the connections one transistor on top of another, where they are both in series, where the Q2 at the top of Q1 and the input applied to collector to emitter. The input for the second transistor are from collector leg of first transistor, and output will be measured on the collector leg for the second transistor, and our input source, input voltage AC source, will be inserted on base leg at the first transistor. The output of signal Q1 at the collector leg of transistor 1 become an input signal for Q2 or transistor 2, where this signal will be influence the base and collector current for the transistor 2. The advantage of these configurations, the cascode can produce very high input impedance and low voltage gain to ensure the input mil capacitance at a minimum, with the collector to base stage provide good high frequency operations. The advantage for this configuration that we produce very high input impedance, so means that this configuration can catch up very low signal input from outside, and it will produce and amplify the input signal become output signal. However, it only capable to produce low voltage gain at the output stage. For these configurations, we play around more in current divider. So we must know how to start and how to compute all the current. First step is, first we should start from Q1. Second, we give name at the base. So to more clear, we can see on the whiteboard. Okay, if you got this kind of circuit, you should start from the Q1 at the base leg. So I'm label is 1. So we know that the current entering the base Q1, we call it IB1. So from IB1 we can derive the IE1. the IE1 equal to 1 plus beta 1 IB1. Right. The second step, you give a derived equation for IC1. So IC1 equal to beta 1 IB1. Alright. And then after that, we can derive for the second stage. So as we already know, for the fourth, IC1 is equal to IE2. If you see here, IE2, current for emitter Q2 is equal to IC1. So, from that we know that IE1 equal to beta 1 IB1. So, equal to IE2. Alright. So, now to derive the next current IB2 and IC2, we need to do a reverse engineering. For the IB2, the relation with the IE2 is IE2 equal to beta 2 plus 1 IB2. So, we already know that IE2 equal to beta 1 IB1. So, we replace it inside the equations. So, first we need to rearrange back the first equations. It become IB2 equal to IE2 over beta 2 plus 1. Then we replace IE2 with beta 1 IB1. Then we got new equation for IB2. So, since we know the IB2, then we can find the IC2. So, IC2 equal to beta 2 IB2. Then we replace IB2 with new equation for IB2. So, the result for IC2 is equal IB2 times IB1 times beta 1 over 1 plus beta 2. Alright. This Cascode, we play more with the current divider. It because the current are separated when the current meet the junctions. Alright, now we settle all the current around the transistor. However, we doesn't know the current at the left side, at the resistance before entering the base leg. So, how to derive the equations? So, we must start from the top. So, we just give name the current flow before entering the base transistors 2. We name it as A1, I1. So, at these junctions, we know that the current will be flow into two sides. The current source is from I1. It will be separated, or it be derived, or it will be current divided into two sides. So one side is IB2 and another side will be going down. So I name it as I6. So at the I6, we can conclude that I1 equal to IB2 and I6. Current entering will be equal to current output. So the current out will be IB2 and I6. So from that we can derive that I6 equal to, we bring IB2 to the left side. So I6 equal to 1 I1 minus IB2. Right. So we already know that IB2 equal as beta 1 IB1 over 1 plus beta 2. So we know the current entering the I6 is 1 minus the beta 1 IB1 over 1 plus beta 2. Alright, so now we settle on the 6th point. Now we look at the last point at 7. So as same theory like previous, the current I6 entering will be separated into two sides, IB1 and I7. So I name it as I7. So I6 equal to IB1 plus I7. So now we need to know what is I7 is. So I7 is equal to the current input I6 with minus with IB. So we replace is what is I6 is. I6 is from here minus with IB1. So now we have covered all the current separated or divided between all the junctions. Another crucial part for these sections, there has a relation between this voltage, the right side voltage will be equal to the right voltage, the left voltage equal to right voltage. So I name it, the right voltage is voltage at A, and the left side of voltage I name it as voltage B. It because it do a parallel, voltage are equal. So voltage for the right side we have VBA plus current entering the times with the resistance RE. So VBA plus 1 plus beta 1 IB times RE1. So this both produce a voltage at the A point, and it equal with the voltage at the left side. The voltage at left side is current entering the R3. So the current entering I3 is 1 minus beta 1 times IB over 1 plus beta 2 minus IB 1 times with R3. This is a second relations at the voltage A and B. Okay, now after we know how to find IB, then we can calculate an IC. So after that you got the value of IC, then you can proceed to do AC analysis. So in AC analysis rules, if you found inside your circuit has capacitor, you need it short its circuit. And if you found that has a DC voltage source at the circuit, you make it ground, right? So if this capacitor getting short, okay, in these cases, if the short here, the current will flow into this wire, and the current not flow into the RE. So we can neglect that RE, and then we will change or the VCC into the ground. So after we draw back, after the transformations, we found that the RA will be disappeared, and also R1 become disappeared because two leg of R1 connected with the ground and ground. So no current or voltage entering the R1, so we can neglect the R1. Okay, to make the more simpler, as I advise you guys, so you start connection from the base Q1. So to transform them into the smoke signal, the BA, the B and A for the first transistor we have R pi 1. So R pi 1 is connected between E1 and B1. So from this leg it will connected to the R3, where the R3 will connected to the ground, and also connected with the R2, where the R2 also connected to the ground. And then at the same point it will connect to the AC source. We call Vs our input voltage. Okay, now we settle the connection for the first transistor. Alright, and then we see the leg of collector to emitter transistor 1. Okay, in this leg it connected with the leg of emitter for transistor 2. We name it E2. So we name it E2. Right, from the E2, the emitter will be connected with the base. Emitter 2 will be connected to base 2, where the base 2 will be connected directly to the ground. So we name is R pi 2 connected directly to the ground. So at the R2 we have V pi 2. Okay, now we have done for the leg base for the Q2. Now we left on we rely on the collector leg Q2. So we name it C2. So in between collector to emitter 2 we have a current. We name it GM2 V pi 2. Right, so GM2 V pi 2, there's a current between collector to emitter 2. Then the leg will be connected to RC, where the RC connected to the ground. So we have RC connected to the ground, and last but not least we have RL. At the same point they connected RL with the ground. So RL with the ground, and end of RL we have V out, that we need to measure our V out. Alright, after that I recommend that you guys to make it simpler circuit by your parallel this parallel resistance. You need to parallel two parallel resistance, so it become more simpler circuit. And our circuit become like this. So we name it RBB is R2 parallel R3. We name it RBB. And RC parallel RL we call the RL prime. So we call the RL prime. So if you got these equations, you got these transformations, LC signal transformations, now you can compute our gain. So our gain is V out over V in. So V out are located at the right side. So the current entering the RL prime then we can measure our V out. So V out equal, and the current entering the RL is inverse from the GM to V pi 2. So to getting the V out, we need give the minus GM V2 V pi 2 times RL prime. Okay. Okay. Before we look at our input side, we need to find the relation between V pi 2. What a relation between V pi 2 and V pi 1. So we need to find relations. So relations between these two voltage located at E2 at this side. So at E2, we know that the current flow insert to GM1 V pi 1. So the current flow from GM2 V pi 2 plus with current from R pi. So current from R pi is equal voltage over resistance. So V pi 2 over R pi 2 is current entering another junctions. So we conclude that the GM, this a current output, and between this junction two current input. So GM1 V pi 1 is equal to GM2 V pi 2 plus V pi 2 over R pi 2. V pi 2 over R pi 2 we generate another current. So now we have two term relation between V pi 1 and V pi 2. Okay. So we rearrange our equations. I bring out all V pi 2 to outside. It become V pi 2 bracket GM2 plus 1 over R pi 2 bracket. And then to make in the same denominator, so I times R pi 2 over R pi to make GM2 equation are equal with the 1 over R pi 2 equation. So it become GM2 R pi 2 plus 1 over R pi 2. Okay. Okay, now I want a relation between V pi 2 and V pi 1. So I need to, what is V pi? I want to know what equation for V pi 2. So I bring all the right side into the left side. So we know that V pi 2 equal to GM1 V pi 1 times R pi 2, because it's divide in the right side. We bring the left side become times, and this time bring the left side, it become divide. So GM1 V pi 1 times R pi 2 over GM2 R pi 2 plus 1. Alright. Now we know the relation between R pi 2, V pi 2 and V pi 1. So so we can replace V pi 2 with the relation of V pi 2 and V pi 1. So after we replace the V pi 2 equation, we can get a new V out. So our new V out is equal minus GM2 bracket GM1 times V pi 2 R pi 2 over R pi 2 GM2 R pi 2 plus 1 times R L prime. So I bring inside GM2 inside the equations. So we can realize that they have two, GM2 R pi 2 and GM2 R pi 2. So if GM times V pi, it equal, if GM times R pi, if GM times to R pi, we got a new relation is equal to beta. So we can replace the GM to R pi 2 into the beta. So it because GM to R pi 2, it become beta 2. So we got new equation for V out. V out equal to minus GM1 V pi 1 bracket beta 2 over beta 2 plus 1 times VRL prime. Alright. Okay, we done with the V out equations. Now we try find the equation for the input voltage. So since Vs, our input voltage are parallel with our V pi 1, so if the voltage are parallel, means that Vs, our voltage input, is equal to V pi 1. Voltage input also equal to V pi 1. So to implement our gain formula, where V out over V in, where the V in or Vs equal to V pi 1, we replace the equation for gains. V out equal to minus GM 1 Vs or V pi 1. Okay, before that I replace the Vs equal to V pi 1 inside V out. So after that we need to find the AV. So AV equal to V out over Vs. So the equation become minus GM1 Vs bracket B2 beta 2 over beta 2 plus 1 times RL prime over Vs. So 2 Vs we can cancel, and the final equation become minus GM beta 2 over beta 2 plus 1 times RL prime. And then if you try to replace these equations, you can realize that if beta 2 over beta 2 plus 1, the value is almost 1. If you put inside the calculator, let's say the B2 is 100. So 100 become, and then this become 100 plus 1 become 101. So 100 over 101 is almost 0.99. We can say that this value are equal to 1. So if we replace this value become to 1, for the final gain, that we can conclude that the AV equal to minus GM RL prime. Simple like this. Our last equation to find our gain. That's why this type of configuration produce not very large the voltage gain. Okay. Now in this slide it gave us examples, the circuit with the values. So this question asks us to compute the approximate small signal voltage. So the example require us to do practice to find the AV. by the parameter given is beta 2 and beta 1 is equal, and VBE it become equal to 0.7, where the VT is 26 millivolt or 0.026. So we can do analysis, DC analysis, but implement the DC rules. The DC rule said if you has a capacitor, you need to open circuit. So this side will open, and then the AC voltage source become short. It's okay. This side will open, and then you can transform your circuit into the DC equivalent circuit, okay, like this. And then, like we have discussed, you can label in advance where the IB, IB2, and also you derive current for the left side. If you realize that all the current label are in form of IB1, all those in IB1, to make our calculation more simple. So first you need to implement is, you need to find loop at the left side, outer loop at the left side. For first equation, so we know the voltage drop here is R1 times R1, and then plus voltage here is I1 minus B1 IB1 over beta 2 plus 1 times R2. So we know the voltage drop here. And the last, the voltage drop at the R3. We know the current entering is I1 beta 1 IB1 over 1 plus beta 2 minus IB times the R3. And the voltage input equal to voltage output or voltage consumption. So the voltage consumption here equal to VCC. So VCC is our input. Okay, this is for first relation equations. Then it because we have two value that we unknown. First we have IB, and second we have I1. So we need to find another equation to make a relations to replace what is I1, and then after you replace I1, then you can find IB. So you need to another equation to make a relations. Okay. The second relation is, we can assume that the voltage at the right side, we call the voltage at A point, is equal to voltage at the left side at the B point. So voltage at the right or A point, we know that VBE plus current entering the resistance RE. So RE times 1 plus beta 1 times IB for the A, voltage at A point. Then it equal with the voltage at B point. So voltage at B point is current entering the R3. So R3 times 1 minus beta 1 IB1 over beta 2 plus 1 minus B1. So we have another relation between IB1 and I1. So after you got this second relations, and then you can plug in or fill in the value of resistance, all resistance, to make a simpler equation. From the first equations, we plug in the value for all resistance, and then we found that (7k 76k I1 plus 28k I1 minus 150 IB over 150 plus 1 plus 70k times 1 I1 minus 150 IB over 150 plus 1 minus IB equal to 15. So 15 is our VCC. So after you plug in, you open the bracket and then you simplify it, then you got the first equation is 141 I1 minus 101.74 IB1 equal to 50 milli. Okay, this for our first equations. And then from our second equation, you plug the value for the resistance, and then you found, after you open the bracket and make simplify, you can got the result is 37 I1 minus 526.75 IB equal to 0.7 milli. Okay, therefore you can replace the value so after that, from this equation 2, you rearrange and make it equation into name of I1. So bring IB to the right side and divide by 73. So you get new equation for I1. So from the I1, we name is 2. So we insert this equation 2 into the equation 1. The equation 1 we have found previous is 101I 1 minus 101.54 IB1 equal to 50 milli. So now we replace I1 that we just get into the equation 1. Then after that you rearrange, and then you get the IB equal to 6.47 microampere. So after you got the IB 1, so you can find and calculate for the IC1. So IC1 equal to beta 1 IB1, and then you can get 0.97 milli. And then after get the IC1, you can find for the next stage is IE2. IE2 here equal to IC1. IE2 equal to IC1. So IE2 also 0.97 milliampere. So after you got the IE2, and then you can make a reverse engineering to find the IB2, because IE2 equal to 1 plus beta IB1. So IB2, so rearrange back, IB2 equal to IE1 over 1 plus beta. So new value for IB2 equal to 6.42 microampere. So after you got the IB2, you can find the IC2. IC2 is beta IB2, and then you get new value for the IC2 is 0.964 milli. Okay, after you got all the value of IC1 and IC2, IB1 and IB2, you can proceed into the AC analysis. Like what we already discussed, after you apply the AC rules, capacitor will be short, and DC voltage will be ground. Okay, and then like we have already derived inside the whiteboard, we got the small signal circuit like this. And then we already derive our V out, and then we already get the relation between the V pi 1 and V pi 2. Then we get the relation between V pi 1 and V pi 2, and we plug in back inside our equation of V out, and then we got in term of beta, and then we make a simple where beta 2 over beta 1 plus beta 2 equal to 1. So we got the final equation for our AV equal to minus GM1 RL1, like we had discussed in the whiteboard. So just using this equation to find our AV. So we just need to compute the value of GM1 and RF prime. So what is GM1? GM1 is equal to IC1 over VT. So we got a 37.3 milli AV, and then RL prime is RC of parallel with RL. So we got 2.5 kilo ohms. And finally, we need to product these two, GM1 times RF prime. So the result is our AV equal to minus 93. Okay, so what I realized that for the cascade, we can get our gain factor or gain multiplication around 34k volt per over volt. However, for the Cascode, only get around 93. So this proves that Cascode circuit only produce more voltage gain. Okay, that's all for this chapter. Okay, and then next I will post another video for the Dalton pair connection. Okay guys, thank you. Assalamualaikum. Before we end up our class for chapter 2 part 4b, please scan your attendance and fill out your details. Okay, thank you.